All right, I realized that I didn't have any of this extra fun scientific notation stuff in my videos, so I wanted to get a couple examples in your hands. So two things that we're going to use with scientific notation is multiplication and division. And there are a couple different ways that you can go about multiplying with scientific notation. One thing that some students will try is when they look at the example that I have here is they will convert these numbers to standard form. So for instance, put 3.5 times 10 to the negative third into 0.0035 and then also convert the other number into its scientific notation, multiply them, and then turn it back into scientific notation because that's what they want. They want the answer in scientific notation. However, that's going to require a calculator, and there's actually a shortcut that we can use here to make this a little bit easier. So this is a route you can take, but if you don't have a calculator, for instance on an MCA, you're going to want to use the shortcut instead. So what we do here is actually we change things around. Everything here is being multiplied. So the commutative property says we can reorder multiplication and it's not going to change the answer. So what I'm going to do instead is group my 3.5 times 4. I'm going to put that together. And then I'm going to times this by my tens grouped together. So 10 to the negative third times 10 to the negative 8. And like I said, since everything's being multiplied together, this is fine. We can do this. 3.5 times 4 comes out to 14. And then we can use our exponent laws, same base, and we're multiplying, so we can add those exponents together. So negative 3 plus negative 8 gives me to the negative 11th. However, this is not our final answer because we are not in scientific notation. So a couple different ways that we can look at this. One, to put it into scientific notation, we could look at what this number should be. It should be 1.4, right? And this would be times 10 to the first power because 1.4 times 10 is the same thing as 14. And we also have that then times 10 to the negative 11th. And what we can do then is add these together now. So same base, we can do 1 plus negative 11, and we get 1.4 times 10 to the 10th. Negative 10th, sorry. So this would be our answer in scientific notation. The other way to try to do this is to just be more of a visual person and look at it like this. So I'll erase this. Okay. Sorry. So this is times. All right. We know that our decimal is sitting right here right now. This is telling me that I want to move my decimal to the left. We also know that this decimal is going to move one spot to the left. So we are taking away one spot that it needs to move to the left. So 1.4 times 10 to the now negative 10th because, like I said, we are moving it one spot in the direction that it wants to go. All right, real quick, we'll go over two of these. Division, same exact thing. The shortcut we can take here, we can do 2 divided by 8, that's 0.25, or 1/4, times. Now, since we're dividing, our exponent law says I can take 5 minus negative 3, which is actually 5 plus 3, and get 8. Okay? So you can use either one of those two methods I just showed you to put this into correct scientific notation. So one way, again, let's say we were doing the visual route, we could do, we know that this exponent wants me to move 8 spots to the right. I'm going to be moving my decimal one spot to the right, so I'm taking away one spot that it needs to move. So 2.5 times 10 to the 7th. And you can always check to see if those come out to the same number by actually moving the decimal spots that many spots and see if it comes out to the same number. So that's another route. And like I said, you can use either route that you want to. The one that I used before, where you turn that first number into scientific notation and then combine it with your tens and go that route too. So lots of different options. All right, last one. and I'll go through it kind of quick here. So 15.75 divided by 1.5 comes out to 10.5 times, and again we're going to take -2 minus 3, so we get 10 to the -5th. Here's an instance where, well, actually kind of like the example we went on the first screen, this decimal wants to move to the left. We are going to move it one spot to the left, so 1.05. So we took away one position that it needed to move, and now we're at to the -4th. So real quick, let's say you got one that looked like this, 11.4 times 10 to the 5th. All right, so not in correct scientific notation. This decimal wants to move to the right. We are going to have to move it one spot in the opposite direction. So we are adding a spot that it's going to have to go, and now this would be to the 6th. And like I said, the other option would be to do it the more mathematical way, is to just turn this number into scientific notation. That would be 1.14 times 10 to the 1st power times 10 to the 5th, and now we can add these together and get the same thing that we just got, times 10 to the 6th. Okay. Sorry for the length of this one. I will go over this in class, but it's one skill that you're going to need because there is a quiz on this. So anyway, if you have any questions, please let me know. Thanks.